Hey, we're going to go ahead and continue. This is part 2 of the video. So for this question, you need to read through these answer choices, A, B, C, and D. These all have little descriptions with what's going on. So this question at 30 says, which list above includes chemical changes only? So remember, evidence for a chemical change would be production of a precipitate, like a brand new substance, changes in color, smell, examples like cooking, any type of baking or cooking example, burning a candle, the change in the color of the wick. Anytime you see like burning in general, production of a gas, etc. So reading through these answer choices, you see it like A, there's a spoon tarnishing, leaves changing color. Tarnish would be like kind of similar to rust. You're getting a new substance. Leaves changing color, you have a change in color, and water separating into hydrogen and oxygen. Any type of thing where you're dealing with like elements of the periodic table and whatnot, you're probably dealing with a chemical change. So that's a possibility. B, if you look at all these like melting, dissolving, tearing, that's all physical changes. This one, anytime you run into a physical change, you know it's not going to be the right answer for this question. So ice going from a solid to a gas, no, that's going to be physical, so that's not right. And anytime you're mixing stuff, that's probably going to be physical, so your answer is going to be A. All right? Moving on to 31. What items correspond to X and Y in the table? What terms correspond to X and Y in the table? So we need to label the descriptions for X and Y. So if you notice for X, it contains only one type of atom, cannot be broken down, can exist as a single atom or in molecules. Y is contains more than one type of atom, can be broken down, only exists as molecules. So if you look X and Y, if you can break it down, that's probably going to be more than so an element for Y, and then X is going to be, for Y is going to be a compound. My bad. Compound Y. And then X will be an element. Alrighty? So X is element, Y is compound. So it's going to be choice B right there. 32. Wind power is used to pump water from the ground to generate electricity. The most likely positive environmental impact of using wind power is, so we're looking at the positive environmental impact of using wind power. A reduction in the use of fossil fuels, the release of carbon dioxide into the atmosphere, disturbing native plant and animal populations, accidental killing. So C and D are not right because that is not a positive. Release of carbon dioxide into the atmosphere. No, that's not a positive. So it would be a reduction in the use of fossil fuels. 33. When plants undergo photosynthesis, what type of energy is converted into chemical energy? So if you look at this, what type of energy is converted into chemical energy? If you look through these, what do plants take in to make their own food? That is the process of photosynthesis. So what do plants take in to make their own food? It more than likely is going to be light energy there. So now we move on to 34. We have obviously Mohs hardness scale here. So using the hardness scale above, not below, but above, which would be the hardness of a mineral that can be scratched by a penny, but not by a fingernail? So the hardness scale above, which would be the hardness of a mineral that can be scratched by a penny, but not by a fingernail? So hardness of a mineral that it can be scratched by a penny, so we need to find the penny, about a 3 to 5. Okay, so if the penny's going to scratch it, it's going to be below. But a fingernail cannot scratch it. So it's probably going to be right in here. Because if the fingernail cannot scratch it, it's going to be stronger, so it's going to be higher. But if a penny can scratch it, it's going to be lower. So we're actually going to drop right in here to calcite. It's 3 for B. 35. A student wanted to conduct a series of tests to identify minerals. Which list below shows the test that the student should conduct on each of the minerals? So when scientists test properties of minerals to determine what they're looking at, they do things like look at its luster, which is its shininess. They do the streak test. They look at its color and hardness. So in all honesty, it's going to be choice B there, all right? Because they're not going to taste it. So those three are up. They're not going to taste the mineral. But anyways, we're moving on to 36. This is also Mohs hardness scale. It's just set up left to right instead of top to bottom. But a student found a pretty rock while hiking with her family. She discovered that the rock will scratch glass, but not her steel knife. According to the Mohs hardness scale shown above, what does the student know about the rock? Okay, so this person discovered, it's similar to the other question. So she discovered that the rock will scratch glass. So we have glass here. So the rock is going to scratch glass. But not a steel knife. So if it's going to be a mineral that is like stronger than glass, so it's going to be like on this side. But then we also found out that it won't scratch the steel knife. Okay, now the rock, she saw a rock, so we're figuring out what mineral it is. So it's going to scratch glass. So if it's going to scratch glass, it's obviously stronger than it. But it cannot scratch the knife, so it's going to be lower than it. So it's going to be like right here in the middle between the two. So we don't have like choices of this now, but we have descriptions. So we need to read through all the descriptions and find the best choice. So it is harder than quartz. So where's quartz? It's harder than quartz, but softer than topaz. No, not right here. It is harder than corundum, but softer than gypsum. Okay, well, to me that doesn't really make sense. It is harder than calcite, okay, but softer than fluorite. No. And then it's harder than fluorite and softer than quartz. Harder than fluorite, softer than quartz. Okay, well that makes sense. And if you notice off the actual exam, that's the answer. So the answer is D, okay? D right there, like dog, okay? So 37, when a cow eats grass, it chews the grass and then swallows it. The food ends up in the stomach where it is further broken down and absorbed. The energy and matter from the grass is used by the cow's body to produce milk. What energy transformations occur in the cow during the entire process of using grass to produce milk? So we need to find out like the energy transformations that occur during the cow while it produces the milk then. So looking through these, chemical to mechanical, no, because there's more to it. So light energy to chemical energy, no, it's not really like a plant. Chemical energy to electrical, no, it's not going to be electrical or inside the body. So chemical energy to mechanical energy to chemical energy. Well, that makes sense. So the food ends up in the stomach where it is further broken down and absorbed. So when the food's in the stomach, it's going to be chemical. Chemical changes happen. Mechanical energy is obviously going to make the cow move. And then chemical energy, since it's producing milk, like a whole new substance, then we're back to chemical energy. So it's going to be choice D. Okay? 38. The use of which of the following resources would be most affected by changes in weather? The use of which of the following resources would be most affected by changes in weather? We went over one similar like this in class, but it's going to be A, wind, all right? Because anytime you think about it here, weather changes, we're probably going to have changes in wind. Which of the following energy resources would be the most environmentally friendly way to add to the electrical power system? Most environmentally friendly way to add to electrical power system. So environmentally friendly would more than likely, yes, would be A, solar panels on the roof, because the other ones will give off some pollution in some way, shape, or form. Number 40, which of the following correctly lists an advantage of using natural gas? So we think about natural gases. Natural gas is a fossil fuel. It's non-renewable. It releases sulfur and carbon dioxide into the air, and can be used to heat home. All right. So we're looking honestly for an advantage. The A and B are true. They're just describing it. It's not really an advantage. C is telling you about a negative. So it's going to be choice D. It's actually telling you about an advantage of a natural gas. Now we have a chart. We have abundance of elements in living organisms. So it's telling you that oxygen in living organisms is 65%, carbon is 18%, hydrogen is 10%, nitrogen is 30%, and there are other elements inside each living organism, 4%. According to the abundance of elements in living organisms table above, most mass of living organisms is made up of which two elements? So it's asking for the most mass, like which two. It's going to be these two at the top, oxygen and then carbon. Okay, there's the top two. The chemical symbol Ca represents, you had bookmarked a periodic table at the beginning of the year, and you can go and look that up on a periodic table and find out what it is. So you should do that. But if not, I'm going to go back to my computer here and click on this website. It's like ptable.com, and you can kind of see, you'd be able to go through this, and if you look, Ca is calcium right there. Okay, I'm going to go ahead and go back here, and which of the 43, which of the following is not an element? If you know it, great. If you don't know it, then you could go to that website and find all these on the periodic table, and the one you don't find will be the correct choice. You will see helium is on the periodic table. You'll see nitrogen is there. You'll see sodium is there. However, water is not there because it is made up of hydrogen and oxygen, so therefore water is a compound. So letter C. 44. Compounds are pure substances. What other chemicals are considered pure substances? Your choices are mixtures, elements, solutions, and gases. So compounds are pure substances. What ones are also considered pure substances? That's going to be B, elements, okay? I'm going to actually click back to the actual final. All right, 45. Which of the following examples represents the greatest amount of potential energy? So you got to think of each example and think about what would have the greatest amount of potential energy. So a spring door fully stretched, similar to the bow and arrow example, if it's fully stretched, it has a lot of potential. So that could be a choice. Water flowing through a hose, that's moving, that's kinetic. Nope. Yeast growing in a petri dish. Nope, kinetic. A helium balloon rising in the air. No, it's gaining tons of potential, but it's also still in motion. So it's going to be A, screen door, fully stretched. 46. Philip throws a basketball up in the air and through a hoop. Because the ball is acted on by the force of gravity, the ball will, you're basically describing what the ball will do and picking the right choice. So the ball will, the force of gravity is going to pull it down. So you guys know, like when you throw a basketball up in the air, it's going to go through a hoop, but it does stuff. So it's going to slow down, I'm reading A. So slow down, change direction, and then speed up until it hits the ground. Speed up, change direction, and slow down until it hits the ground. No, B doesn't sound right. Travel at the same speed and same direction until it hits the ground. Nope, it's going to be choice A. It's going to, like, you think about even a baseball being hit at a ballpark. So it's like hit and it goes up, slows down, kind of like pauses for a split second, so it has tons of potential. Then it's going to change direction and start to come down and speed up. That's like when it's losing potential and gaining tons of kinetic till it hits the ground. Okay, so it's A. 47. Mr. Norton is taking his baby for a walk in a stroller. The amount of force that Mr. Norton must use to make the stroller move most likely depends on the stroller's direction, distance, mass, or velocity. It's going probably to depend on the mass, okay? How much mass, how much stuff is really that object is made out of, okay? So it's mass. Now we have 48. We have, trials 1, 2, 3, and 4. We have the distance the car rolled in centimeters, but we need to figure out 4. And then the type of push, if it's gentle, medium, strong, and medium. This one is kind of using a lot of prediction type skills, but David placed a toy car on a flat plastic track. He pushed the car and measured the distance the car rolled. He followed the same procedure 3 times. His results are recorded in the data table, which is a good explanation and estimate of the distance the car will roll in trial 4. So if you notice, you have, let me get my pen. Here we go. I'm going to use a different color now for this video, maybe green. So if you notice, the push is gentle, 12. If it's medium, it's going to go probably up a little bit. So 12, 13, 14, 15. So like you do, we do, let me pull up my calculator. We do 17 minus 12. So we know that that went plus 5. Oh, I probably need to write on here. So I'll scroll down to this. You can see the right answer, but on that picture, like that trial 1 to 2 was plus 5. Okay, then you have the next one between the next 2. It went from a medium to a strong push, so it's still going up. So on my calculator, I'm going to do 23 minus 17. So that's going to be a plus 6. And then strong to medium, well, it's going down. So now we know this is going to go down. If you notice, like we had plus 5, plus 6. So since the distance the car rolls decreases when the strength of the push decreases, so it's going to decrease, all right? It will roll approximately 18 centimeters, so 23. Let's do 23 minus 5, because it was like plus 5, plus 6, it went down, so we'll do minus 5 just to kind of counteract these two. It's like a prediction method, and we do get 18, so the correct choice on this will be letter B, all right? These two talk about increases, and then this one talks about a decrease. What was I going to say? I'm sorry, I had like a brain freeze there, but it's not going to be A or C because these both increase. I said that wrong. It's not going to be D because the push doesn't increase, the push decreases. So we know that's stated incorrectly. So it's going to be decrease because both of these will decrease, and we did minus 5 from 23, so that'll be 18. So the correct choice is B, not D, but B. Okay? Alrighty, moving on. We're getting close. We have 50, 51, 52, 53, and 54. So Coach Cornwall is choosing students for the track team. There are 4 students who want to compete in the 1,600 meter race. The school's track is 400 meters long, so the students will each run 4 laps. The lap times and total times of the 4 runners are shown in the data table above. Which student's race results is plotted on the graph? Okay, So we see each student's race results here. All right, we just need to figure out which one is plotted on the graph. So what you would do is go through each of these, and you can see this is lap 1, 2, 3, and 4. You would go through each of the kids and see if their times match up to the times on the graph. If they do, you know it's that kid. So for lap 1, it looks about 1.4, so it's Jose here. For 2, it looks about like 2. I don't know, 15-ish. So the only one really that close is Jose because he's 2.17. You look at trial 3, we have about 1.40 again. And the only one close to that is Jose again. And then you look at trial 4, it went up to what, like about 2.08. And yep, he's the only one at 2.08. Okay, so the correct answer for 50 is Jose. A toy car rolls 8 meters in 2 seconds. What is the average speed of the toy car? So do remember, if I travel to that question here, we see the right answer, of course, but do remember that if I use my pen, and this is the formula for speed, it's distance divided by time. So the distance is 8, okay? So we have 8 divided by the time of 2. So 8 divided by 2 equals 4. So 4. Now, we need to know the correct unit of measurement. So remember, this was meters, and then this is seconds. So it's going to be meters per second, right? 4 meters per second. The next one, 52, we have a graph. So students begin to measure the speed of the ball rolling down the ramp. Some of you could get confused because it almost looks like this is the ramp and the ball's rolling down it, but don't get confused. This is just a graph of the results. So remember, as the ball rolls down the ramp, the speed will probably, like the distance will increase, the time will increase, and the speed will increase. So if you look, the graph is showing that, okay? The graph shows the results. What is the average speed of the ball? Like the average speed of the ball. So really, when we're calculating that, we just go right to the end. The end points are 5 and 20. So remember, I can only type on the actual screen here on Chrome. So I'm going to go to this question. Where is it? This one. So I did say on those results that you go right to the end point, like the end of the last 2 points here. So we see that the time is 5 and the distance is 20. So remember, speed again is distance divided by time. So our distance, remember, is 20. And then our time is 5. If you divide these two on a calculator, you'll get 4, all right? So it's going to be 4 meters per second for number 52. Number 53, when a car is on an icy roadway, it is difficult to control its motion. What best explains this phenomenon? What do you guys think? What would explain the phenomenon of the car controlling its motion on an icy roadway? Well, really, it's friction. It can control the icy roadway if it had friction, but this example is telling you that it's difficult to control its motion because of friction. So the icy road does not supply enough friction to the car's tires, and therefore the car kind of swerves everywhere. So then, looking at question 54, the moon orbits the Earth. During the course of this revolution, the moon's speed remains constant at 3,600 kilometers an hour. Which graph below best illustrates the moon's speed over time? Okay, so If you notice, when it says constant speed, we know that the time and distance are going to be like increasing at a same velocity. So therefore, at the same rate. So like, therefore, the line will just travel up. Great. Okay. This one would be like decelerating. Okay. This one's all over the place, like lots of changes. And then this one is not constant. If you notice, like on this one, the time is increasing because time doesn't stop, but the speed is not changing. All right. So that's not constant. Constant would be like constantly accelerating, but at a constant rate. Like if it goes up a second, the speed is up like, a meter, or like 2 seconds, then another meter. So it keeps traveling up. So the correct choice is A. All right, make sure to study, and you'll do well in your final. All right, see you then.